I'm Francesco. I really like to travel and looking forward to do that again, which is also why I'm maybe only, I don't know, 75% fit today because I got my second COVID vaccine shot yesterday. So I could feel better, but I'm happy that I feel well enough to hold this talk at least. I work at FabScale, which is a small company. We build software for coffee roasters. You can imagine this, roughly speaking, that we collect data from all the machines in a roasting plant, sync it into the cloud, and then we have a cloud application where you can see your KPIs, your production data, do quality control, and things like that. I lead the technical team there, and I'm also heavily involved in actually writing the front-end application. Our stack is an Ember app, which we use for the front end. It's a fairly up-to-date Octane app. We have a Java-based GraphQL API and a little software called the Cloud Connector, which runs on-premise in the roasting plant, which is built in C#. I will be focusing on the Ember part, especially on like how we communicate with our GraphQL API. For that, we use Ember Apollo Client, which has been around for some time and works quite well for us. I've seen quite recently, there is also a new add-on Glimmer Apollo, which also looks very nice. I have not looked into it in detail, but generally what I will be showing you should not really be tied to Ember Apollo Client itself, but be more like conceptually how we handle things. So this talk is not really about GraphQL itself. So the goal is not to really explain GraphQL in detail. There are a lot of resources on that. I just want to give a very short overview for those who maybe don't know anything about GraphQL. You might be more used to working with REST APIs, with something like Ember Data, a REST API where you have an endpoint per resource, where you get or post or put requests to do certain things on these endpoints. In contrast, GraphQL has a single endpoint where you just always post to, and the type of action you're doing is defined by the payload that you send. And you can send either a query or a mutation to either fetch data or to do something. The way this works is that you have a static defined schema where you have types, which is basically a model. So you could have a user type, which has certain fields. It could have an ID, a name, an email. Maybe it has a company relationship, and maybe it has a roles relationship, for example. When you now write a query for GraphQL in your own application, you can basically define which fields you want to have. So in the top left code box, you can see we want to do a user by email query where we have one variable, which is an email. And what we care about is the ID, the email, the name. And for the roles relationship, we want only the ID and the name as a simple example. On the right side, you would see the payload that you would get for such a query. It's basically a POJO in the structure that you defined. And on the bottom box, you see how you would actually invoke such a query with Ember Apollo Client. Basically, Ember Apollo Client provides you a query manager, which is basically a service, kind of. This has a query and a mutate method that you can use, and you can pass it a query and variables, and then it will invoke this, and it will return a promise that resolves to a POJO. Very high-level overview of GraphQL. If you are interested in learning more about GraphQL, there are a lot of great resources out there, and I can recommend it. We have been quite happy with it. One thing that might also be good to mention is we have a GraphQL API, and we use Ember Apollo Client. So what is Apollo compared to GraphQL? Apollo is basically a specific implementation of a GraphQL client. This is non-Ember specific. I think it's mostly actually like the normal Apollo client is built mostly for React, I think, but you can easily use it in an Ember app as well. And what Apollo client basically does is it brings certain things on top of just the basic GraphQL functionality with it, especially also the caching. If you are used to maybe Ember data, this brings a certain level of caching out of the box, and it also has its issues. Basically, you fetch records by ID, and then these records are stored in the cache, and you can basically fetch them from there without hitting the network again if you want to. Apollo also has something like this out of the box. And the way it works for Apollo is that a full query is cached. This means that if you have a certain query with a certain set of variables, the first time you do it, it will be cached. When you have the same query later, it will not hit the network again, but just return you the same response than before. This generally is nice and works well, but we found it to be potentially tricky when working a lot with mutations. So, and also with ensuring that no data becomes stale, because our application can be quite long-lived. You can imagine a person in a coffee plant pulling up our web application and just having it open the whole day. Now, the way that Apollo caching by default works is, let's say I fetch a list of tasks in the morning, and then 10 hours later, I fetch the same list of tasks again. I will get exactly the same responses before, but I probably just want to hit the network again at that point. So this is a short example of how this caching works in Apollo. Basically just description of what I just said. So the first time you have a query, it will hit the network. And when the promise resolves, you have the POJO. Now, when I do exactly the same query with exactly the same set of variables, again, at any point later, it will not hit the network, but just give me the same response again. If I use the same query, but with a different set of variables, it will hit the network again and then cache this again. So the cache is really per set of variables and query. Now, if you bring mutations into this, you can quickly see how this can become a bit tricky. So let's say I query a user. I want to get the user by email for francesco@fabskill.com. Now I have a user object. At some point later, I run a mutation. I want to update a user, and I want to update my name to Francesco Smith, let's say. Now, if at any point later I rerun the query to fetch my user by email, it wouldn't necessarily know that I have run a mutation in the meanwhile, and it will just return me the same user that was fetched initially, which is not what I would want here. In this case, I would just want it basically hit the network again. Apollo does provide tools to work with that, because obviously it's a common use case. So the way this is normally handled is that with a mutation, you can have kind of a callback. So when the mutation is done, you get access to the cache object more or less. And there you can basically manually update the cached responses for the different queries. That's quite powerful, and of course can be very performant, because you can really avoid any duplicate lookups or network lookups. But for us, this became quite annoying quite quickly, because you have to write a lot of kind of low-level code, or it feels kind of low-level. Let's say you have you update a username, then you need to fetch any query where you have ever fetched a list of users and make sure to update it accordingly, etc., etc. So it's possible, but for us it felt kind of like not an ideal solution. We wanted something where we define more or less the rules of how we want the caching to work, and then we don't really need to think about it anymore later. What we ended up building is a pretty thin layer on top of Ember Apollo Client, which allowed us to easily define how we want caching to work. And to do that, we basically only use the fetch policy that Apollo already provides. So for any query, you can define the fetch policy, which by default is cache first. Cache first means if a cache exists, it will return the cache. If no cache exists, it will hit the network and then cache the response. So what we ended up doing is made a small function that determined if a certain query should be cached or not. If it should be cached, we would just set the fetch policy to cache first. And if we decided it should not be cached, then we would set the fetch policy to network only to ensure it will always hit the network. And then we more or less kept the map of the different queries and when they were being made. We do not manually work with the Apollo cache. We do use the Apollo cache, but we do not directly interact with it, only over the fetch policy. And when we run a mutation, we're allowed to define a list of caches to clear, basically. I will show some code how that works. So the usage is relatively simple. The way we implemented it is we have a service per entity. For example, let's say we have a user entity, then we would have a user store that has all the methods for interacting with users. So we would have load user, create user, delete user, update user, for example. These store services use the store manager, which is a shared service, which is basically this SYN wrapper on top of Apollo. The way you would then invoke it is more or less similar to the way you do it with Ember Apollo Client. Most of the things are just passed through. The relevant thing really here is the cache entity and the cache ID. So we allow to give cache entity, which is really basically a namespace for how store this, and optionally an ID. And then you can also define a cache seconds, which is after this amount of seconds, we want the cache to be invalidated. This means, for example, we say load users after 300 seconds. If this query is made again, we always want to hit the network, no matter what happened before. And this basically helps us to avoid stale data. Something like this might not be relevant for every use case, but for us, it works quite well. Now, if you have a mutation, it's pretty similar, but instead of defining how you want to cache it, you can define a list of caches to invalidate. And you can define either just a cache entity, which will invalidate anything where no ID is given, so basically any list query, let's say, and you can define a cache entity in combination with an ID. So in this concrete example, after we update a user, we want to clear the cache of any query that basically returned a list of users, and we want to clear the cache of any query that returned this single user with this email, as an example. How does this work below the hood? At the end, it's quite trivial, I would say. We have a method that checks if the cache should be used. I will show this afterwards. And then we set the fetch policy, either to cache first or to network only. And that's really basically it. Key thing then is how you implement the method to check for cache usage. This might depend a bit on your business logic. The way we have it is we have a store cache, which is basically a map of maps. So it is a map per entity type. And then each of these map items has another map per ID, more or less. So we can always look up when was the last request made for this given ID or for this given name if I don't give an ID. And if this is old, I can update it, and else I just say no, keep using the cache. And then on the other hand, when I run a mutation, all we do is clear the cache for this specific entity type. So the next time the check should use cache method is run, it thinks that this method has never been run, and it will always try to hit the network. That's basically it, how we handle caching. It, of course, might lead sometimes to a bit more API requests than necessary, but it is a really hassle-free solution for us. We can always just use the store manager methods and not think too much about, or do I need to somehow force this to reload or something like that? But it will just always go through the normal path when I invoke something. Now, the second part I want to talk about shortly is how we then actually use our queries in our application. And for that, we use Ember Could Get Used to This, which is a really awesome add-on. If you haven't looked into it, I would heavily recommend to do that. We use it everywhere in our application now, and it has really changed how we write our Ember applications. Ember could get used to this, provides multiple different things. I will be focusing now on resources. So a resource is a kind of helper-like primitive that allows you to work with asynchronous things in a reactive way. The key thing is it has a value property which returns something which you can then use. And this is auto-tracked, so you can really return whatever you want. In our case, we have a value that returns is loading data and is error, which are normal tracked properties. Now, the interesting thing is the lifecycle hooks that a resource has. So it has a setup hook, which is called when you call it the first time, and a tear down hook, which is called when it should be destroyed. The normal behavior, when an argument changes, it will tear down the resource and set up a new one. You can also provide an update hook, which will then instead be called if an argument changes. You can have positional and named arguments, and yeah, it behaves mostly like a helper in that every time one of them changes, the setup or update hooks will be called again. So this is a really straightforward example. On setup, we use Ember concurrency to basically use a service method and set data to something, or if there is an error, we set the error property. And then the normal tracked behavior will lead to value being updated, and value is then what will be exposed to the application. You invoke this like a helper. We group all our resources in a app/helper/resources directory, but you could put it anywhere in your helpers directory, and it works pretty straightforward. The really nice thing with that for us is that it doesn't force you, but it really makes it obvious to always have loading and error states, because like whenever we create a resource somewhere, the syntax is always the same. It's always if resource is loading, else if its resource is error, else it's a success. And this makes it much easier to not accidentally kind of drop some potential error state somewhere under the table. Before, the really other options, if you want to do something like that, is often you might have a method, let's say load user, which you can invoke from your constructor, which works. But A, you need to make sure to catch errors, save the error somewhere on the component, and also expose this somewhere. And B, the tricky thing is what happens if you want to be reactive? What is if the email address changes? If you invoke the method from a constructor, this will not work very nicely. You can then use something like the did update helper in your template, but this is also kind of a hack really and not a nicely reactive solution. And with the resource, it's really pretty clear what's happening, really easy to follow. And the added benefit is also you can also use them in not only in a template, but you can also use them in a JavaScript file. There is an add use decorator that you can use, and then you can also reference the value normally in your component, and it will react to any changes in a reasonably followable way. And basically with these two things is what I would be consider our thin layer on top of GraphQL. It works well for us. It might not work well for everyone, but I hope there was maybe something interesting in there for any of you. I will also share the slides with the code. You can look at it later if you want to, if you're interested in some of the code maybe. And yeah, if you have any questions, feel free to reach out.